All right, so today we're talking about multiplying and dividing rational expressions, okay? Still, the main thing, the overarching thing with either adding, subtracting, multiplying, or dividing is you need to know how to factor, okay? So we're still going to do that. We're still factoring not just the bottom, but also the top, okay? And then because we're multiplying, we cancel out factors that they have in common. And since it's multiplying, it doesn't matter if it's right on top and right on bottom of each other, but we cancel out common factors. Now there's one more thing that I didn't address the first time that I need to address now is a lot of times with rational expressions, you're probably going to have to state a restriction, which means that there's a number that's going to make this rational expression undefined. Okay? Now, if you have a fraction, what number makes a fraction undefined? Zero. So basically, once you've gotten your rational expressions into factor form, before you start canceling stuff out, you figure out what your restrictions are. X cannot equal 4. 4 minus 4 will give me 0. So x cannot equal 4. X cannot equal -3. And x cannot equal -5. All three of those numbers would make one of these fractions a 0 in the denominator, making it undefined.
So it's just like finding the 0?
Yeah, of the denominator. Okay? So before you start canceling stuff out, once you get into the factor form, state your restrictions and then cancel. So let's look at an example. Okay? We need a factor. We're going to factor all parts, top and bottom. Up here, there's no GCF. What two numbers multiply to give me -3, add to give me 2?
2 and 1. Or yeah, 3 and yeah. 1 and 2. 3 and
3 minus 1.
3 and -1.
Yeah.
Can I factor the bottom?
No.
Nope. What about the top?
Yeah.
I can take out an x. That leaves me with what?
X plus 2.
X plus 2. And what about the bottom?
X plus 1, X minus 1.
X plus 1, X minus 1, because those are perfect squares. Now before we get to the next step, let's state my restrictions. X could not equal what number? -2, -1, or +1, because any of those numbers would make one of these denominators 0. Okay? Yes? Because we forgot to do it the other 2 times, so I need to address it now. But yes, with rational expressions, more than likely, there will be a restriction that's stated. In other words, what value x could not be. Okay? Yes?
Then you have to put x cannot equal, so you just be like x cannot equal -2, -1.
Yes.
Right.
Why is it not 3?
Why is it not 3? Because I can plug in 3 into any of these and I have a number at the bottom. So if wherever x plus 2 equals 0, x plus 1 equals 0, x minus 1 equals 0, where any of your factors equals 0. So there's no 3 at the bottom.
What's the third one? 1.
Now from here, you cancel out any common factors, okay? Do you see anything that's the same at the top and the bottom?
Yeah.
X plus 2, so those cancel out.
X minus 1.
X minus 1, those cancel out. Why can I cancel those out?
Multiplying.
Because you're multiplying. I'm multiplying everything together at the top and everything together at the bottom, so I can cancel this way. If it was a plus, I can't do that until I put them together. Okay, but because this is multiplication, this is the same thing as saying x plus 3 times x minus 1 times x plus 2. All of these things are basically all together into one fraction. So then I can cancel out everything that they have in common. And then whatever's left over is my final answer. I have an x, an x plus 3, and an x plus 1. And that would be my final answer.
How come you don't multiply the top like that?
Because I'm not going to go with that extra step. I mean, you can, that's fine, but I will leave it. I'm going to leave it there. Yeah. Okay? Just that simple. Factor, state your restrictions, cancel. Okay? Look at the next one. Factor the top.
It's x times x plus x minus 2.
Greatest common factor there.
It's x plus 1 and x plus 1.
At the bottom, because I'm looking for two numbers that multiply to give me 1, add to give me 2.
On the other side, it's x plus 3 and x plus 1.
Two numbers that multiply to give me 3, add to give me 4.
Then on the bottom, it's x times x plus 3.
So you factor just like before. You factor just like before, all your pieces. Before we start canceling, let's state my restrictions. X cannot equal what number?
Negative 1 or
Negative
negative 3.
Negative 1.
Mm-hmm.
Negative 3. There's one more.
0.
Yeah, 0.
0.
Because if you
Because there's
multiply
an extra
that.
x outside of it.
Okay, so whenever there's an x, an 8x, 4x, 2x squared, if there's an x on the outside, it cannot equal 0. Now let's cancel. X plus 3s,
Yeah.
x plus 1s.
Okay, so you can't cancel both.
Yeah, just one, because there's only one at the top and one at the bottom. And the x's. So that leaves me with x minus 2 over, and that's my final answer.
Wait,
Okay?
but why cancel the x plus 2? Okay. So
Alright.
x minus 2.
Oh,
X plus 1.
It's gonna get harder.
I want you to try the next
Wait,
two
whoa, whoa.
on your
Wait.
own. Try the next. So here's your answer for number 2 with your restrictions. Sorry, not number 2, number 3. And number 4 with your restrictions. Now, dividing rational expressions, okay? Very similar to multiplying, you just have to do one additional step, okay? And I've talked about this before when we've dealt with fractions, okay? When you divide fractions, you're basically multiplying by the reciprocal, okay? So when you're doing it with rational expressions, you're gonna be doing the same thing. You guys remember me saying keep, change, flip before? This is what you're gonna have to use here, okay? Keep, change, flip. So, you do the same like before, you factor, okay? The top, I can take out a GCF
2x.
of a 2x
X squared.
Yeah.
squared. So then that leaves me with x minus 6. I factor the bottom, two numbers that multiply to give me negative 12.
Negative
Actually,
6 and 2.
I GCF the top, that is a 8x squared, and x plus 3 left over on the inside. The bottom two numbers that multiply give me 18, add give me 9, 3 and 6. So the same first step, just like before. Now before I go stating my restrictions, this is where I do K, C, F. I keep my first fraction. I keep my first fraction. The C stands for change. I change my division to multiplication. And the F stands for flip. That means I flip the second fraction. Meaning whatever was on the bottom comes to the top, and whatever was on the top comes to the bottom. And now this is just like how the other one was, because it's multiplication. What are my restrictions?
X cannot equal 6.
6, and equal 6.
Negative 2.
Negative 2.
0.
0,
Negative
and negative 3. Again, all we're doing is we're just taking each factor, setting it equal to 0, and solving.
3. Why not 8?
Because it's 8x squared. And when I set that equal to 0, when I divide both sides by 8, I still get 0. Take the square root, x is 0. Alright? Now cancel. What can I cancel?
X plus 3.
Wait, minus.
Minus 6.
Plus 3.
No, equal.
Negative.
You can do the, you can divide the 2 and the 4, or 2 and the 8, so you can get 4 and 1.
Yep, those cancel out. They both have the 2 in common, so this becomes a 1, this becomes a 4. What about the x squares?
They go away.
They cancel out as well.
So you use it as like 2 separate ones, I guess?
What are your ones?
It'd be x plus 6 over 4.
X plus 6 over 4 times x plus 2.
Over 4 times x plus 2.
Yes.
That will be my final answer. Okay?
Does it get hard? It's not that bad. Yeah, it's not, it's just like a lot of, but then sometimes I do it easy and then it gets harder and
Just factors, that's mostly what it is. Alright? I'll do one more with you, now I want you to do 7 to 8 on your own. Can I factor anything here?
Yeah, you can take out, you can take, no, you can take 12 out of the 12x.
Mm.
Yeah, 'cause it can be 4x.
This is monomials, they can't really be factored. These are all monomials, can't factor these. So, I go to my keep, change, flip.
Yeah.
Keep my first. Change to what?
multiplication.
And then it becomes
5/36 xy squared.
alright?
Can you,
My restrictions here will be x cannot equal what?
0.
And y cannot equal 0. That's all good. Now, do they have anything in common with the top and the bottom?
Yeah, 12.
They have a 12. So if I take 12 out of these, what am I left with?
4.
And a,
3.
anything else?
No, because it's not an x squared, it's an
X, X,
They just have one x in common.
Yeah,
So I take away one of these x's,
and you,
and then I can get rid of this one.
okay. So it would be 4x.
And Y.
Y's on the same area, so I can't cancel anything out.
So that's the same
20
channel.
X.
Well, 5
Yes,
4x.
what has to be on top of it?
20x over y to the third,
20x over
3y.
3y to the third. Because you have 4 times x times 5, so that's 20x. Then you have a y times a 3y squared, which is a 3y cubed. Okay? Take 2 minutes and do the next two. Can't factor the top, but I can factor the bottom. And because there's no factoring done here, I'm just gonna go ahead and keep, change, flip. Okay, and if you want to, you can keep, change, flip, and factor in the same step, if that's what you wanna do. Okay, it's your choice. Alright, my restrictions here, x cannot equal 0, x cannot equal 1, and x cannot equal -1. So when I start to cancel, I know x plus 1's cancel out, and then this x here can cancel out with one of these x's up here because it's being multiplied by the 3, not being added. So then my final answer will be x over 3 x minus 1. Raise your hand if you got that. Alright, and then on to the next one. You gotta factor a lot in the next one. Let's see how well you factor. Okay? Here, I'm looking for two numbers.
X
X
plus
plus
2 and 2x plus 1.
Whoa. Oh, I didn't.
Alright? That's good old California method right there. The bottom is difference of perfect squares. That's a 2x plus 1 and a 2x minus 1. Both of those are perfect squares, guys. So that should have been the factor for the bottom. Here, go ahead and flip them so I don't have to keep writing this over and over again. So when I factor this, I'll have a 2x minus 1 and then an x plus 1.
And X plus 2 over X.
X plus 2 over x minus 1. This is what you would get after you factored and you keep, change, flipped. X cannot equal
Negative 2.
-1/2,
Positive 1/2.
positive 1/2,
-2
-2,
and 1.
and 1. Those are the values that x cannot be, or else I'll have 0 in the denominator. And so when I cancel, I have some x plus 1s. I have the 2x minus 1, and I have an x plus 2. Leaving me with just x plus 1 over x minus 1, and that is your final answer.
Wait,